Hello, this is Johnny Castles from Prime Academy, and for today we are going to find the derivative of 7 over x using the first principles definition of a derivative. So what we want to do here is first of all understand what the first principles definition of a derivative is. It's kind of a spooky looking statement at first, but it's actually not too bad when you break it down into just 3 parts. So part 1, we have the fx plus h. Part 2 is the fx, and the part 3 is the h in the bottom. As you can tell, and I'll use a Barbie Corvette pink for this, if we were to make this h 0, we would end up with a divided by 0 situation, which means it doesn't exist. So we can't just sort of start there and end there. So we're going to have to take a few steps here to be able to use this and then actually find out what the derivative is. So the first thing we're going to do is we're going to find out what fx is. That's actually pretty easy here. It's just 7 over x. And then we're going to have to find out the expression for fx plus h, which will be, if we remember with function notation, whatever's inside the bracket is what we replace x with. So here, there's our x plus h, so I put it in the bottom where the x and the x are. So now that we have two of the parts that plug into our equation, we can actually just substitute it in. So let me change colors here. So up here, going back, and when I say up here, I'll just put a little arrow back on this equation. You can see that I'm going to replace the fx plus h with 7 over x plus h. And again, to just use some color coding here, that's because this and this are the same thing. So I'm going to replace it with this. Now for the fx, that's just 7 over x. And again, sort of same idea. I'll use a different color here. You can see there's the blue there. There's the fx there, so I'm going to replace the fx with 7 over x. Now what we do is I write the divided by h. At this point, I still have the issue of the divided by 0, but when you look at the numerator, we can see that we have subtraction involving fractions, which means we have to create a common denominator. And to create a common denominator, what we do is, since these are expressions containing variables, we just kind of end up multiplying the two like denominators that have variables in them. So my common denominator, which I will call CD, is just going to be x plus h times x. So what we end up doing is, limit as h approaches 0, is the x that's in the denominator here, I'm going to multiply the other numerator by x, and for the x plus h that's in the denominator here, I'm going to multiply it up in the other numerator, where the purple arrow is. Again, this is just the standard creating a common denominator. So we end up with 7 times x, and then minus 7 times x plus h, and all over, and I'll write it twice actually. Let me undo that. I'm going to write it twice just so you can sort of see that we've created that common denominator. We have x plus h times x, and then we have x times x plus h. And what I'll do is, again, I'll sort of color code things. So we have here, there's the x plus h's that we kind of multiplied in to create our common denominator. And here are the x's that we multiplied in to create our common denominator for the other term. And then don't forget, this is all divided by h. So we're going to do some simplifying now. And just as a heads up, what are we looking to do? The h that has the little green arrow next to it, we're looking to cancel that. We're hoping that it's going to cancel, so then we no longer have a divided by 0 situation. So I'm going to do some simplifying. So 7 times x is just 7x minus 7x minus 7h. And so what I did is that negative 7, I just distributed it in here using the distributive property. Now, since both of the denominators are the same, we made a common denominator, I can write this all over a single expression, x plus h for x. And you can see that's the same common denominator that we have up here. And then again, let's not forget, this is all divided by h. Now there's going to be another line of simplifying here. So the limit is h approaches 0. So 7x minus 7x is nothing. So then I'm just left with minus 7h over x plus h over x, and then again, all over h. Now, when you have fractions divided by fractions, you want to flip and multiply. So here, watch this. I'm going to kind of put this in brackets, and then I'm going to put this over 1 and kind of put this in brackets, or technically parentheses. And you can sort of see it's a little bit more visual, or a little bit more obvious that we have fractions divided by fractions. So what I can do is I can rewrite it like so. And there's my x plus h over x, now times. Now remember, this h over 1 is going to become a 1 over h because you flip and multiply when you're dividing fractions. And if you take a look here, what's going to happen is that we have these h's diagonally across from each other, so I can cancel them. And so when we fully simplify on our last step here, the limit as h approaches 0, we're going to have minus 7 over x plus h times x. And now we're in a situation where we can plug in 0 for h. And remember our h, I'll just mark it off right here in pink. That h is now x plus h. So if we make it equal to 0, the denominator doesn't immediately become 0. So what we'd be left with, if I evaluate the limit by plugging in 0 for h, I end up with 7 over x plus 0 times x, which then equals minus 7 over x times x. And running out of space here, but I can squeeze it in, minus 7 over x squared. And there is your derivative.